Hello, this is Mr. Ferreira, and this is part of the first year research methods course. It's a very kind of simple section that I'm going to label or call descriptive statistics. Now, it's a part of the course that relates to your GCSE maths. So therefore, I'm not going to teach you the maths. I'm perhaps going to show you some of the things that are relevant to psychology. And one of them, of course, is this name, descriptive statistics. So in other words, descriptive is a form of describing or somehow showing a picture of what the data looks like. And the best way to do that is to either do a table of data where we have some summaries of data. And we find that mean, median, and mode are one ways in which we can summarize data. The person who is looking at our report is not interested in raw data, but these summaries. So the first summary of data comes under the heading of measures of central tendency. Okay, so therefore we know central is kind of middle, in the middle, that type of idea. Okay, so central tendency is something to do with some kind of middle point. Another way of referring to this would be an average. Okay, so how can we collect or show average data? The first way, of course, is to use the mean. Now, of course, I think you all understand what the numerical mean is. It's simply adding up all the scores and dividing by the number of scores. Simple, not meant to be difficult. All I would say is for your psychology exams, if you have a calculator, it can certainly makes this a lot more easier. But in terms of research methods, we are concerned or interested in how we would use mean and what the advantages and disadvantages are. And I suppose most of us kind of know this, that the mean can be very useful if we do have scores that are clustered together. And so therefore it can give us a good understanding. So for example, if I was looking at kind of a mean of the ages of sixth form students, you'll see that, to be quite clear that most of you will be 16 or 17. Okay. However, we do also know that an extreme score can also throw that out. And I suppose if you kind of miscalculated and you said the average age of the people in this room, and I was in the room with you, my age would throw out that average significantly, so much so that none of you will actually be anywhere near that mean. So very simple, not exactly the most difficult situation. So we see, for example, that if you saw that the average or mean wages of a company is £20,000, you might be interested in taking a job, only to be disappointed to see that actually you only earn £10,000. Or if you were looking at a party, it may well be interesting for us to see the mean age, kind of who do we kind of cater the party for. So as I said, not meant to be desperately difficult, but I would like you to at least be aware that you are expected to understand the mean. The second one is median. This is literally the central number in a set of data. Of course, my reminder there is that you've got to put them into order. You can't find a middle number unless they're in order. And of course, if it's an odd number, it's very simple. There is actually a middle number. But if it's an even number, it has to be the midpoint. So we kind of take the two middle numbers and we average them out. So of course, what is good about the median, of course, is that it's not affected by extreme scores. And of course, it says here best for ordinal data. So this is best for data that can easily be put into order. So if I was looking at kind of performances in a test or something along those lines, it may actually be quite good for me to see kind of where the middle number is. But of course, it's not very sensitive, and it's not sensitive because we don't use all the data. And so therefore it could be misleading in many ways. Some people turn to the mode, and this is the most common number. It can be slightly confusing if there's not a common number, but of course, we need to recognize that if something happens more than once, it often kind of tells us something about the data. And so, of course, the advantage is it's not affected by extreme scores, and it's one of the few ones that actually has to be one of the scores that we collected, and so therefore it kind of will make a lot more sense to us. And what we also like about this is that the nominal data, so data that can only be put in categories, can certainly be used. So, for example, if I'm kind of looking at what subjects people take at A level, and I go around counting kind of how many people do maths, how many people do English, how many people do, and I could potentially find um, the one subject that you kind of mostly do in terms of where's the commonality and things like that. But of course, if you have more than one mode, this can be quite confusing. And of course, it doesn't really tell us much about data. So, for example, at the party data, there was both a mode of 2 and 14, and that doesn't really kind of tell us much. So why don't you spend some time just looking at these sets of numbers? You might want to pause and then work out the mean, median, mode. This is good practice to be able to do it quickly and accurately. You don't want to waste time in an exam, and also equally, you don't want to make silly mistakes. If you're able to do this, then put down the answers and you can check the answers on this particular page. So there we have measures of central tendency. And please remember that phrase, central tendency. The other phrase that they ask us to look at is measures of dispersion. So dispersion is perhaps a word that you don't hashtag that often. So think about kind of what it means to disperse, so kind of spread out. So this is going to be measures of spread. In other words, how are the scores spread? And the easiest one to look at is range, and this has got to be the easiest score. You simply take the highest score, take away the lowest score. Now there's a bit of a confusion of whether or not you should add the +1, and in my experience of looking at the mark schemes, they include both the +1 and without the +1. I'm always kind of down to accuracy in terms of numbers, and so therefore, I'm happy to take the lowest and the highest. But the +1 comes into effect that, of course, things are often rounded up, or if there's decimal places, that could indicate certain things as well. But for me, I'm just simply using the range as to be kind of the highest score, take away the lowest score. Now, of course, as I said, absolutely easy to calculate. There's no real difficulty in this. However, the disadvantage is, of course, once again, extreme scores are the thing that kind of work against us. And also, it doesn't really tell us much about how the scores are actually grouped. So it's those measures of dispersion, and that was about spread. And I'd like to kind of see. So this is looking at how far apart the biggest and the smallest are, but nothing about the in between. So that means we have to look for something else. Now, mean, median, mode are things that you have done before, and range. So the next way of looking at things would be to consider, well, what is the next step? So we see here that we have two classes that would have similar means and similar ranges. So not similar ranges, but is there something we can tell about these scores using something else as the measure of dispersion? So we see class A, even though we have people with the top marks of 80, 90, and 100, but we also have some of the lowest marks as well. So could I, they both have the same mean. Let's think of something else. And so statisticians came up with something called standard deviation. And I suppose this can be complicated, and in the maths course you might be expected to calculate this, but you definitely do not need to calculate this for psychology. But what it really is, it says here, it's the average variation from the mean. So what they do is they take the mean score, and then we see the mean score being 55. And then we take each score individually and we say, well, how far away from 55 is that? Okay, so that's 45. That's 45 as well, okay? And it takes that average distance from the mean score and then works the mean of that, okay? And what happens, it says the difference between the mean and each score. A lower the score, it means that the distance between them is lower. So for example, we see this class B set of data here, is that each of the distances between the mean average and the actual score is actually quite a small number. So we're looking at about actual distance there. And if I average that out, that will give me a lower score. So if that is the case, it means the scores are actually clustered together, which is very helpful for us. So therefore, the standard deviation is a way of checking that. But we do not need to know how to calculate it. Now, it's really good because it's quite powerful for us to use, and it takes every score into account. So that's why I can do a comparison between two sets of data and the standard deviation and get an understanding of what I should do. However, it is hard. People conceptually don't get their head around it. And of course, something which takes us to the next level talks about normally distributed data. So in other words, if data is meant to kind of have a reasonable spread, then standard deviation really works for us. But if it's not, then it might be kind of challenging for us to understand. So there we go. We have an understanding of mean, median, mode. Now, with this little slide, I just wanted to put kind of an asterisk next to mean, median, and mode and say that when we look at distribution, so when we're looking at graphs, there's a special set of graphs that we have to be able to draw, but it's based on the mean, median, and mode, and not on anything else. And obviously, I just want you to remember kind of what the mean, median, and mode are before we get to that section. So I haven't included every other form of calculations that you might have to do in a test, but I want to remind you about fractions as part of a whole, because you could get reference to 3 out of a group of 15 participants kind of acted in a particular way or had a particular score, and they might ask you to kind of do some kind of comparison of that fraction. So we see here 120 participants, 40 of them were in condition A. So that could ask, well, what fraction of the participants were in study A? Now, of course, the only thing I just want to remind you of is fractions are exactly kind of as they say, 40 over 120. So 40 over 120, and we always kind of cancel it down to the smallest value. Okay, we see that 40 over 120 is a third. You also might be expected to do percentages. We certainly refer to 5% significance, and 5% as a decimal is 0.05, something which is very straightforward, but I expect you to kind of understand that as well. They could ask you to work on a percentage. Okay, so this is often where your understanding of a percentage of and what percentage are doing something will be helpful to you. Now, the last thing I want you to recognize is when we do work on fractions and certainly using a calculator, we might get answers that look a bit like this, 0.527777778. Okay, so there's something called significant numbers that you need to consider. And basically the rule of thumb is if I've used 2 digits there and 2 digits there, okay, if I write that, I've used 3 digits. We ignore this bit because it doesn't tell us anything other than it's less than 1. So I need to count 1, 2, and that would be 3. So if I was writing that decimal as in significant figures, I'd actually write it 0.53. I do round up because that's important for us because this digit is over 5. And so therefore, that is showing the answer to 3 significant places. Now, or they could use 2 decimal places as well. Okay, so please consider kind of being sensible using your maths. If you do A-level maths, try not to overcomplicate this. The purpose of this is for you to mostly just have an understanding of how to do some of the basic calculations. The other one they also ask us to look at is ratio. I recommend personally looking at BBC bite size, getting a bit of practice. But we also know that at Seneca Learning as well, there's also an app. I haven't logged in, so I'm going to have to go back to my slide. And you could use your Seneca Learning to practice your maths. And there's also a whole section on psychology as well. So I'm going to bring this video to an end. There's not much to fill into your booklets. There's a page that says do the advantages and disadvantages of mean, median, mode. You can certainly fill that out. And then I would say just make sure that you kind of practice the calculations that you should do. If you are weak at calculations, then you should go back to your GCSE maths, your bite size, any of those types of things, and give it a go. Don't be scared of it. It's important that you get these marks because they often are worth, marks without much effort. Thank you. That's all I'm doing. Okay, goodbye.